Welcome back, everybody. Today we are talking about solving more complex equations. So we've talked about solving literal equations, aka formulas, and we've gone through equations that have variables on both sides and ones that have some distributing and things like that. So this is just a reminder of the exact same things that we went over in the last set of notes. So just a reminder again that you need to have out your class notebook and you need to be writing these down as we go. So you need to pause the video so that you can write the title, you can write all this stuff that I have written down here. You can do it a little as you go, or you can leave space, but make sure you're getting all of this down because a lot of times I'm going to ask you to refer back to your notes, and so if you don't have them all complete, it makes it harder for me to help you. So, our first more complex equation in A is more complex because we've got decimals. Now, in the last video, we had an example where when we went to divide, our answer didn't come out evenly. It wasn't an integer. And I said that we only use decimals in 3 situations. 1, if there's a decimal in the original problem, which is clearly the case here. We've already got decimals in the original problem, which means that if our answer is a decimal, that's okay. The other situations are if the directions specifically tell you to round or any word problem. It's pretty much always okay to use a decimal in word problems. So we're going to follow our same general steps here. First, we need to look at the individual sides to see if we can distribute or combine like terms. On the left side, this is a constant, this is a variable term, so they're not like terms. Nothing I can do on the left. On the right, variable term, constant term. So nothing I can do there either. Step 1 is already done. So step 2, move all the variable terms to one side of the equation by using inverse operations. Now, I had told you in the last video that it doesn't really matter which side you move them to, especially if you've also got constants on each side. This is going to be a matter of personal preference to you. Some people always like their variable to be on the left. Some people don't care which side it's on, but prefer for their variable to be positive. I like for my variable to be positive just because I know that students tend to make more mistakes with negative signs. So I am going to, because I know that 0.2 is bigger than 0.15, I'm going to move my variable terms to the right by subtracting this entire variable term, the 0.15x, on both sides. So subtract here, those will cancel out, gives me a 4. Then over here, I've got 0.2x minus 0.15x. Remember, you're always allowed to use a handheld calculator. I had suggested a TI-30X. This is an XS because those have fraction buttons too, and they're pretty user-friendly. So 0.2, and I'm subtracting 0.15. Enter, and that gives me 0.05. So I have 0.05x, don't forget the x on it, and then I've still got this plus 6 over here. So step 2 is done. All my variables are now on the right. If my variables are on the right, my constant terms have to go to the other side. So that means my constants need to go to the left. So I'm going to move this constant that's on the right using its opposite or inverse operation. So it was addition, I do subtraction. 4 minus 6 gives me negative 2 equals 0.05x. Last step is to get the variable alone. Even though this is a decimal, the operation between this decimal and this variable is multiplication, which means that the inverse operation is division. So I need to divide both sides by 0.05. So definitely want my calculator here, clear that out. So I'm going to do negative 2 divided by 0.05. Enter. and then I get negative 40. So it does actually come out to an integer answer. Remember that we can always check all of our answers to an equation by simply plugging this back in to the equation and making sure it gives me a true statement. Okay, so for B now, my first step, make sure each individual side of the equation is simplified. So I have 2/3 P plus 1/5. Well, this is a variable term and this is a constant term, so nothing we can do there. Right side, nothing I can do because it's just a single constant. So step 2, move all variable terms to one side. Well, that's already done as well. My only variable term is on the left. So here I actually begin with step 3. I'm going to move my constant term that's on the left over to the right by subtracting. So minus 1/5 minus 1/5. Now, because these fractions have the same denominator, you should know how to deal with those. But again, you have the use of a calculator if you don't. The way that we subtract and add fractions with the same denominator is the denominator stays the same and you just add or subtract those numerators. So 4 minus 1 gives me 3. Now again, if you didn't know that, that's okay. You can use this guy. So I can do 4, and then here's my fraction button, fifths, and then press the arrow, minus, and then you can do 1, fraction button, fifth, and then you can press enter, and it will give you your answer as a fraction. All right, so now, more complex equations. This is the first time that we're going to have this situation where we have a fraction next to my variable. When we have a fraction next to the variable, obviously if I'm writing this down, you should write this down too. We multiply by the reciprocal as the inverse operation. So it's special. That's why this is in its own section here. So this would be generally in step 4. So in this case, I need to multiply by the reciprocal of 2/3. So if you don't know what a reciprocal is, then you should write that down as a definition as well. Reciprocals flip numerator and denominator. So this numerator is 2, this denominator is 3. I'm going to switch them. So go ahead and just write down what you believe the reciprocal of 2/3 is. If you said 3/2, you are correct. If you didn't, no big deal. Let's just go ahead and look at this. Flip numerator and denominator. So that means just reverse them, which is what I did here. That is the inverse operation. So these cancel each other out to get my variable alone. Now I have multiplication of fractions. And if you don't remember from when you learned to multiply fractions in middle school, this you don't need a common denominator. You just do numerator times numerator, so 3 times 3 is 9. And then denominator times denominator, 5 times 2 is 10. Again, if that's very difficult for you, yes, you should continue to practice, but please check it on your calculator. I can do 3, fraction button, 5, and press the right arrow, and then times, and then I can do 3, fraction button, 2, and then I can press enter, and notice it gives me the same answer. And that is in simplest form. 9 and 10 don't have any common factors to reduce, so we're done with that. All right, next one is C. So first I look to see if I can simplify the individual sides. So 5x plus 8, nope, not like terms, can't do anything there. Same with the 3x minus 3. One's a variable, one's a constant. Nothing I can do. So step 2, move all variable terms to one side of the equation using opposite operations. So again, doesn't matter which way you go. I prefer for my variable terms to be positive. So I'm going to subtract 3x on both sides, moving them to the left. So 5x minus 3x is 2x. Then I've got my plus 8. These canceled, and I've got a negative 3 remaining. So now all my variables are on the left, which means in step 3, my constants need to go to the right. So undo this addition with subtraction. Got 2x equals negative 3 minus 8, which is negative 11. Again, if you struggle with negatives, there's no shame in checking them in the calculator to help you. Step 4, get the variable alone using inverse operations. So this is a multiplied 2, so I need to divide. If you go to do that in your calculator, if I do negative 11 divided by 2 and press enter, it doesn't come out nicely. It's not an integer, it's a decimal. Do not write a decimal. If it doesn't come out nicely, you need to leave it as a fraction. And so what we can do here is see this button above table where it has F and then 2 arrows D. That means fraction to decimal. I think it also will do decimal to fraction, but let's try that. Second. And sure it does. So all I did was press second because it's in this color, it's above this thing. Then I pressed the button and then I pressed enter. And then it just told me negative 11 halves. So x equals negative 11 halves, which remember, that's exactly what division does. It creates a fraction. So my answer was right here. All right, last of this type. I do not have anything that I can do on this left side of the equation because this is a variable term and this is a constant. On the right side, also variable term and a constant. So nothing I can do there. So that means, move to step 2. I want all my variable terms on one side using inverse operations. So I've got 3/4 and 2/3. Since 3/4 is bigger, I'm going to move the 2/3. Remember, we're moving the whole term in step 2 and step 3. So that means subtracting or adding. These go away. 3/4 minus 2/3. These do not have a common denominator. So you're going to want your fraction buttons help for this. So 3/4 and then do minus 2. Fraction button 3, and then over, press enter, and then I know now that that is 1/12. So 1/12 A is what I have left here, minus 1/6 equals 1/4. So all my variable terms are now on the left, which means step 3, all my constant terms need move to the right. So I'm going to move this constant of 1/6 over by adding it since originally it was subtracted. So I need to do 1/4 plus 1/6. So 1/4 plus 1/6. And that gives me 5/12. So I have 1/12 A equals 5/12. Remember that when I want to get rid of a fraction next to a variable, we multiply by the reciprocal. So go ahead again and write down what the reciprocal of 1 over 12 is. So hopefully you said 12 over 1. So I'm going to multiply both sides by 12 over 1. Remember, that is the inverse operation. That cancels these out so that A is alone. And now you could either multiply these by hand or you can use the calculator. So I've got 5/12 times 12, essentially. So 5/12. And you don't need to do the 12 over 1 since you know that's the same as 12, but if you do, it won't mess anything up. That just gives us a 5 because what ends up happening is these 12s cancel each other out. And so we end up with A equals 5. Okay, so now we've got a word problem to look at. Bags of maple granola cost $2 more than bags of apple granola. The owner of a restaurant ordered 6 bags of maple granola and 5 bags of apple granola. The total cost of the order was $56. Using A to represent the cost of a bag of apple granola, write an equation that models the situation. So this is very similar to what we had with the members and non-members of COSI in the last one. But it says A is the cost of apple granola bags. So we know how many bags we ordered, 6 of maple and 5 of apple. So we know that maple cost plus apple cost equals total cost. And in this case, we know that the total cost was $56. The cost of the apple granola is going to be the number of bags of apple granola, which is 5, times the cost of a bag of apple granola, which is what they just told us to use A for. So now I just need the maple. I know that they've ordered 6 bags of the maple, and I know that maple granola's cost is $2 more than apple. So if apple is A, that means maple is A plus 2. That's why we spent so much time turning words into expressions, because $2 more than means plus 2. So this would be our equation. And now in part B, we're going to find the cost by solving that equation. So first I'm going to distribute. So 6 times A is 6A. 6 times 2 is 12. And we've got plus 5A equals 56. Like terms here, 6A plus 5A is 11A. Plus 12 equals 56. Individual sides are now simplified, and all my variables are on the left. So I move my constant to the right by subtracting 12 on both sides. These cancel out. I've got 11A equals 44. Divide by 11 to get A alone, and I get A equals 4. So we solved our equation. It says find the cost of each type of bag of granola. So A was apple. Apple's $4 a bag. Maple, we were told, are $2 more than apple. So that would be $6, and then we are finished. All right, so hopefully what we did there makes sense, and you're ready to try some practicing on some equations.